So we are going to see about UV visible spectrophotometer. So on this we are going to study about how the UV visible spectrometer has been designed and its functions applications. So it's an absorption spectrophotometry. Absorption means the ultraviolet radiation UV is being paused in the nanometer 200 to 400 nanometers, and a solution depending upon its concentration it observes the ultraviolet radiation. So remember that in one end the light is paused, and in cuvettes you will be having the solution, and it will be traveling through the solution and the light will coming out of that. So how much light will come? So there is a difference between the lights which is getting out of the wavelength which is getting inside and which is coming outside. So depending upon the concentration it will change because there will be an absorption. Okay, yes, it's one of the oldest method. Here we can use a UV wavelength of 200 to 400 nanometer or a visible wavelength of 400 to 800 nanometers. So here three things have been used. One is photometer, spectrophotometer, colorimeter. What's a photometer? It's an instrument to measure the intensity of light. So spectrophotometer, an instrument which measures the ratio or the function of two of the radiant power to the emitted beams. Colorimeter, an instrument which is used to measure the absorption in a visible wavelength. So components: radiation source, collimating system, monochromator system, a sample holder, detector, and amplifier. So here the UV light is passed, and here the dispersing element is here. Certain wavelengths have been passed into a sample container. Sample will observe certain things and it will give out some amount. So I naught intensity of the thing which is getting inside, and I the intensity after emission it has been recorded. So what are the ideal requirements? We should have non-fluctuating radiation ideal source, uniform intensity wavelength. So the light source should be in optimum wavelength. For a source we can use some different lamps, tungsten halogen lamp, which is using household lamps that can be used. It can heat up to 3000 Kelvin temperature and beyond that. So it is a polychromatic light. So demerits, it emits a major portion of the radiation in the infrared spectrum, but we need mostly in ultraviolet region. Hydrogen discharge lamp can also be used. It provides a UV radiation with the hydrogen gas. So a stable UV region light can be emitted by this hydrogen discharge lamp. Xenon discharge lamps can be used. So it possesses with two tungsten filament and inside the quartz bulb. So there will be an xenon gas filled under pressure. The radiation emits. So only disadvantage is it requires a high voltage. So no need to explain these things in your exam. You just mention source of light. You have three different sources. One is hydrogen lamp, ordinary filament, xenon discharge lamp, etc. So collimating system. The collimating system consists of lens, mirrors, and slits. So the lens, an ordinary silicate glass, transmit 350 to 3000 nanometer of light, which is suitable for silica and IR region. So mirrors, which used to focus the light to minimize the light loss. Then slits, So it is a polychromatic radiation. The light which is coming out is a polychromatic radiation. The silt is an important device in resolving the polychromatic radiation. So based on this, we can achieve the radiation in a required format. Then monochromators. We have monochromators like filters, prism, grating. The polychromatic radiation has been filtered and it will be converted into a monochromatic radiations. So the continuous spectra of the wavelength can be filtered and required wavelength can be transferred. So filters, so which has some selective absorption of unwanted radiation. Glass gelatin filters. The source of light in a WebGL region within it is visible, and particularly in ultraviolet region with 200 to 300 nanometers. So it is a cheap way of construction. It's a cheap method, but it's less accurate method. The bandwidth plus or minus 20 to 30 if we have measured in between 400 nanometers. So sample holders is we call this as quartz. It's a cylindrical or rectangular in nature. It is used to study the UV region. It's made up of quartz or fused silica. The surface of the cells, these won't observe ultraviolet radiation. It allows this to passes through. So this is good. Inside which we can fill a sample and place inside the instrument. So detectors. So detectors which detects the light which is emitted out of the sample, and it's converted into electrical signals. The electrical signals have been recorded in the detector, and the detector may be several types which depending upon the requirement we can use. There are 3 types of detectors in ultraviolet spectrophotometers. So one is a barrier layer cell or photovoltaic cell, another one is photoemissive tube or phototubes, and photomultiplier tubes. So ideal condition for the detector is require a quantity response. It should give a quantity response. Highly sensitive, short time response. So this spectrometer classified 2 types. On a single beam spectrometer, the light source gives a light which is passes through a filter. The filter will select the filter and passes through that light. The light will be in only one form. So the single beam, so source, the light is being passing here and it passes through the things. Only one type of light is used. So the single beam instrument is there will be a double beam also. So like this. So the source of UV light is here. You see, the source will passes through the diffracting grating and passes through this, and the light has been split into 2 forms. One it passes to a reference and another one is passes to a sample. So reference, sample. So there will be comparison and the reading will be in the manner that of our requirement. But here there is no comparison. We use only one code here. Only one code can be used here. Okay. Yes. So double beam photometer. So advantages: simple, easy to conduct, economical. So it will double beam facilitates or a large scale of wide range of wavelength region. Fluctuation due to radiation is being minimized. It does not require any adjustment for the 0% or 100% transportation. So it gives a ratio between the sample and the reference, so it will be more accurate. So in single, the disadvantage is any fluctuation in the radiation source will affect the observance. The continuous spectrum is not obtained. In double beam, construction is complicated, instrument is expensive. So in single beam instrument is very simple one. The cost is very less, but in double beam the cost is very high. So thank you. With this, we finish this one and we go for the next class.